Displacement reaction. In this reaction, we generally have a highly active element which has a capacity to displace a less active element from a given compound. Right? The element which is represented in green is more active than the element which is represented in blue. So, these are generally the cations which has a capacity of displacing one cation from another cation. So you can observe the change in the color here. So the blue and the green represents cationic forms, yellow represents anion. So green being active, highly active, displaces the blue color here. Let us go ahead in understanding the further examples. You have copper sulfate made to react with zinc. Zinc is more active than copper sulfate. So what happens is zinc displaces copper sulfate. Zinc takes up the place of copper sulfate and releases out copper. But if you ask a question to me like zinc sulfate made to react with copper, this cannot happen because copper is less reactive. This reaction can never take place. Displacement reactions moves forward for us to make us to understand about the metal activity series. In the metal activity series, we can clearly identify which element can displace which element. The metal activity series, basic series that we have over here is potassium, sodium, calcium, magnesium, aluminium, zinc, lead, iron, and then lead. Then hydrogen. Below hydrogen in the series you will have copper, mercury, gold, platinum, silver, platinum and gold. So you'll have a series which has been decided based on the metal activity and the reactions and their active process. So you'll have a series which we call it as potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, platinum and gold. This series helps us to understand that supposing if I have a compound with lead, I can use zinc to displace lead. But if I have a compound with lead, I cannot displace it with copper. So when you look at this example, what is given over here, zinc is placed much above than copper. So zinc is more active and can remove copper, but copper is less reactive because it is placed very far away, and this cannot displace zinc. So displacement reaction helps us to understand the displacement property only when the element between the elements which are highly active and less active. That's the reason why the first reaction can take place whereas the second reaction cannot take place.